Next, we will continue with the model evaluation. How do we diagnostic how good my model, trained model? Like in the case of linear regression, we have used the metrics like R squared, adjusted R squared, mean squared error, and the root mean squared error. Similarly, what kind of metrics that are needed in order to evaluate how good my model is predicting? What is the accuracy of the model? You have something like, the AIC, archaic information criteria. The lesser the AIC, that model is good. Okay. The lesser the value of your AIC, that model is good. Okay. And apart from this, we have some confusion matrix. Okay. And you have something called ROC, receiver operating character is something like, okay, and area under the curve. In this package, you have something called area under AUC. The AUC, the area under the curve should be 1. Okay, any value which is closer to 1, that means my model is good. And kappa statistic. And when these are all very specific to logistic regression. The kappa statistic, concordance and discordance, and the AIC. This is specific to logistic regression. Even in the case of the linear regression, I discussed Bayesian information criteria, archaic information. I discussed, as part of the model summary. When I explained you the model summary, right, in linear regression, I explained that one. Okay, now what we will do is, these are the metrics that are available. Apart from this, you have something called log loss. In the case of binary classification, use something called log loss metric to measure the model performance. Okay, that is what we use it. We will take a look at each and everything now. Okay, now still we have some more time. What is confusion matrix? So confusion matrix is very much helpful to to ensure that how many number of records or how many number of examples or observations my model correctly classified. Okay, how many of the observations it predicted correctly, good as good, bad bad as bad. That is what we can interpret from the confusion matrix. Once you develop a model, and with the help of confusion matrix, the confusion matrix is also available as a method that is available as part of the SQL. And once you import it, it will give you something, the table kind of thing. Okay, you can see something like this. Look here, in this case, so there are different equations, accuracy. So this is the metrics. So, these metrics, you can derive it from the confusion matrix itself. Okay. So here, true positive plus true negative divided by all these values. That is the one will give you the accuracy. First of all, let us understand what this confusion matrix is all about. So this is what, the predicted value. Let's say your model predicted outcome, and this is what the, actual data. Let's say in your Excel data, you have, let's Jivanandam, right? Jivanandam, is a profitable customer, which means a good, right? I say good. So if it is 0 means he is not a profitable customer, he's a bad customer. Okay, so here, with the help of confusion matrix, I need to check whether, the Jivanandam record has been correctly predicted with profitable or not. Okay, so actually, this guy is a profitable customer. Good, right? Is a good actual thing. But what about the model? Whether my model also predicted him as a good? If it is yes, okay, my model also predicted him as a good and actually is a good, then true positive. And if you look at here, actually, let's say, you have another guy. Okay, let's say Rajesh. Okay, Rajesh is bad. Okay, he is bad. 0 means bad. Actually, this guy is bad. Actually, Rajesh is bad, but my model predicted him as a good. So in this case, what will happen? You are going to approve the loan to this wrong guy. Actually, he's he's a non-profitable customer. If you approve the loan just because of misclassification, with the help of the confusion matrix, we can understand that, how many number of observation has been misclassified. Okay, sometimes what will happen is actually is bad, but my model predict him as good. Sometimes what will happen is the person is okay, the person is actually good, but my model wrongly predict as bad. So this is called your false negative. This is called your false positive. How many of you remember type 1 error and type 2 error? In the hypothesis testing, we discussed it, right? But here, predicting a person is bad. Let's say, the Rajesh is bad, and my model also correctly predicted, yes, this guy is bad. That is called true negative. And another example, COVID test. Okay, let's say you have actually infected with COVID. My model also predicted, yes, you have a COVID. That is true positive. But you have actually infected with COVID, but your model wrongly predicted, you are not having COVID. So what will happen? You will not isolate yourself. You will mingle with all the people. You will keep spreading it. And okay, so here, actually you have, okay, in this case, COVID, right? Okay, let's say, this opposite. Okay, sorry. The year you don't have COVID. Okay, my model also correctly predicted you don't have COVID. Good. But here, you don't have COVID, but my model wrongly predicted, okay, here, not this example, sorry. This example is not coming. Why don't you give me some other example? Okay, let's take the same example, okay? And because I go by the term positive, the medical, if anything positive, then think. Okay, let's take the same example, COVID itself, right? Actually, you have predicted as actually you have COVID. My model also correctly predicted you have true positive. But you have COVID, but my model wrongly predicted that you don't have COVID. Okay, in this case, right? In this case, actually, let's say, the here, okay, sorry, it's bad is coming, right? That's why, okay, here, let's say, positive, negative. We'll say like this, right? Negative. But actually, you have negative here. Instead of I just striked out the good and bad because you will get confused. In the case of COVID, actually, you are negative, but your model predicted you are, this is positive and negative. Okay, you just think that way. But your model wrongly predicted you have positive. Okay, false positive. And actually you have a negative, but your model correctly predicted you have negative. So if you say it's something like this, let's say take for example the court example, criminal and innocent. If my model correctly predict a criminal as criminal, okay, then it is good, right? My accuracy is good. If my model correctly predict innocent as innocent, it is good. If my model wrongly predict an innocent as criminal and vice versa, then it is a problem. That is what your misclassification. Basically, we are very particular about understanding, how many number of misclassifications happen. And also, let's take the same bank example, right? The person is actually good, but my model also correctly predicted, good. But if you approve the loan to this guy, it will be good. But actually, the person is bad, but my model wrongly predicted this guy is uh, you know good. Actually is bad, his records are bad, but my model wrongly predicted is good. In that case, if I approve a loan, it is very dangerous. Even if you approve loan for only one guy like Vijay Mallya, right? You are gone. My model predicted Vijay Mallya is a good guy, and if I sorry to use individual's name. Okay, and if my model actually is bad, but my model wrongly predicted is good. So the thing is the sensitivity. I'm talking about the sensitivity. Okay, here now the question is, okay, how many number of false positive can be there? Here ideally you should have very less number here in the case of bank, because if you approve the loan for a wrong person, you're gone. Bank will become bankrupt. Okay, and if you look at here, a person is actually good, but my model wrongly predicted is a bad. So in that case, what will happen is you are not going to approve the loan, fine, but at least here, you're not at all giving the loan. But here, if you give the loan to a wrong person, you are gone. So in the case of bank, your false positive should be very less. False FP should be very, very less. In the case of bank, let's take, for example, another example, whether customer is going to purchase or not. We want to predict, right? So in this case, let's know the purchase actually is purchase, not purchase. Okay. And my model correctly predicted, yes, he's going to purchase, fine. My model, not purchase. My model predicted, he's not going to purchase, but actually he is going to purchase. In that case, I'm going to lose the customer base, potential customer. Fine. But in the case of cancer example, okay, and positive, negative, right? So in that case, my model wrongly predict the person, a healthy person, right? Okay, actually is positive, but my model wrongly predict is negative. What will happen? He will not undergo the treatment, which means he's going to die soon. Okay. In that case, the false negative, you should have very less value here. You should be, so what we do is, there are two things. The objective of the classification algorithm is to reduce the misclassification. This is what your misclassification, these two things are misclassification, but still on a case to case basis, we need to decide. So in this case, in the case of bank, if you approve a loan to a wrong person, which means the false positive, let you know one person is fine. In this case, my model misclassified 1,000 people. If you give loan to 1,000 incapable person, you're gone. The whole objective in this case is the false positive should be 0 or at least 1 or 2 only. This is the objective. They will set it to you, the customer. My false positive should be very, very less. It should be 1 and 2. That is where you will pose a lot of challenges. As a machine learning uh, engineer or data scientist, you should try to bring this down. Okay, this value, very less, as low as possible. But in this case, you need to bring down this value as low as possible. Whereas in this case, also problem. In the case of cancer, yeah. So actually is non-cancer, but my model wrongly predicts he has cancer. In that case, he has to undergo chemotherapy unnecessarily. In this case, he is not at all, he is supposed to undergo chemotherapy, he is not at all undergoing chemotherapy. In this case, he will die. Even the healthy person also soon he will die, because when he undergo chemotherapy unnecessarily, is gone. So in this case, both the false positive and false negative should be very less. In the case of bank, this one should be less. The false positive should be less. Okay, take for example purchase, right? You want to predict whether customer is going to purchase. This is purchase now. Actually, is going to purchase, is not going to purchase. My model predicted, this customer is not going to purchase. Actually, is a potential customer. Let's say in this case, you have 1,000 potential customers are there. My model wrongly predicted 1,000 customers, false negative. But in this case, this customer, right, not purchase. My model predicted is going to purchase. Even in this case, right, fine, you're not going to, when it comes to monetary, you're not going to lose any money. But when you send any offer or something, then you're going to target wrong people. Fine, but here the impact is not so high, but whereas here it is very high, right? You're going to lose the potential customers. In that case, you need to minimize the false negative. So you should be knowing, based on the domain where you work, whether FP should be reduced or FN should be reduced. Okay, but there are cases both FP and FN should be reduced. But ideally, if you reduce both, it will be good. Okay, that is what. That's how you need to interpret the confusion matrix. Okay, now you understood what is false negative. So negative, it is false. Okay, it is false negative. Actually, it's a wrong. Okay, is actually good. That means a good, but falsely it says is bad. False negative. False positive is actually is bad, but my model predicted is good. Okay, false positive. Okay, actually is not positive. False positive. Actually is not negative. False negative. That's all you need to remember this way. It will be confusing, the confusion matrix. You should not get confused. So even I got confused with this example. Good, bad. If you apply this with COVID, But again, you need to change it with the different positive and negative, right? So with that, it is, I was able to explain it. Okay, next one is the accuracy. Okay, the confusion matrix, with that, you can find out, okay, how many number of values are there here in the false positive, how many number of records got misclassified as false negative. We can see it. The more the value you see it here, then something wrong. When you see more value, you can immediately conclude something wrong. Okay, the model did not do good job. It requires, fine tuning. Probably you may have to do the feature selection and make sure that whatever the technique that you used to do the feature selection is correct, or try with a different feature selection technique like chi-square and other thing. Okay, and then see what are the columns, independent variables you can introduce, which all independent variables you can discard. Even in the case of logistic, there should not be multicollinearity. You need to take into account of all the things, and then see everything, and try to minimize the value, false negative and false positive. But once you develop the logistic regression model, what you do is use up the accuracy metrics. The interview, they ask you, okay, what metrics that used it? AIC, and the next one is accuracy. Okay, what is the formula for accuracy? True positive plus true negative divided by all the value. True positive plus true negative plus false positive, false negative. This is what my accuracy. If the accuracy value is somewhat closer to 1, that means it is good. Okay, if the accuracy value is somewhat close to 0, then it is not good. Okay, the accuracy should be high, and next one is the true positive rate and true negative rate, and this is called sensitivity and specificity. 1 minus specificity. These are the equation. Precision. You have something called precision. Look here. Now we will take a look at what are the difference between accuracy, precision, and recall. Look here. I have mentioned everything here. But recall is something like this. What is the recall? TP divided by TP plus FN, right? TP divided TP plus FN. The sensitivity is also called as a recall. Okay, recall. Okay, and now the question is, do I have to use all these things? The basis for accuracy, recall, and precision is a confusion matrix. This is how you tell. So how did you get the value for accuracy? From the confusion matrix? Okay, and can you tell me accuracy? What is accuracy? The proportion of correct classification from overall number of cases. True positive, true negative divided by total number of samples. That is what your accuracy. And what is recall? And proportion of correct positive classification, true positives from cases that are actually positive. And the precision is proportion of correct positive classifications from cases that are predicted as positive. These two things are, if you see the first sentence, proportion of correct positive classifications from cases until this good. Okay, the second line, if you see, that are actually positive, that are predicted as positive. Okay, now I will explain you when to use which accuracy, which metrics. Can I use accuracy all the time? Can I rely on this all the time? No, there are situations the accuracy metrics is not helpful. It can mislead us. In that kind of situations, you need to use either recall or precision. Okay, when should I use recall? When should I use precision? That is what I'm going to discuss it now. Look here, this is the thing. Okay, see, this is what your confusion matrix. Let's say in this case, you have predicted something like this spam or non-spam. Let's say they have given you a bunch of emails data, and they want you to classify whether it is a spam email or non-spam. Okay, spam is something nonsense. Okay, and non-spam is very important. Okay, let's say your manager sent an email, and that email he detailed out what are the things that you need to do it for the next 5 days. Okay, but if you don't see that email, what will happen? You are gone. Or let's say you cleared the interview, and they are sending the feedback, and they want you to join in 2 days time. They sent an email, but that email went to your spam folder. You did not see for the the last 3 days. What will happen? You're gone. If you call them, I sent an email, you did not respond. you should have joined 2 days, 1 day back, but sorry, we can't do anything. So it is very sensitive, right? So in that kind of situation, how well my model is classifying it correctly. See, basically, in the case of email, the machine learning algorithm is already running. Okay, it automatically classifies which all emails are spam, which all emails are legitimate email, and all spam. If you go to the spam folder, you can find a lot of spam related emails, right? Okay, so in that case, if the algorithm wrongly classify the correct email as a spam, if that legitimate email has important information, you are going to miss it. Let's say you have predicted and then you you have predicted a binary classification problem. Let's in the spam or non-spam, and you have used you predict you have you use the confusion matrix function. You produce the output like this, and you can see the positive. Actually, it is spam, and it is not actually it is not spam legitimate email. So if my model, right, so 2 emails it correctly predicted as non-spam. Okay, sorry, here we are interested in predicting the spam. Okay, my model correctly predicted 2 emails as spam, but here my model wrongly predicted 2 emails as non-spam. Here my actually it's a non-spam, but my model predicted spam. This is very dangerous, right? But in this case, actually it is a spam, but my model predicted as spam. Predicting the spam as spam is correct. Predicting non-spam as non-spam is correct. Whereas predicting the spam as non-spam, predicting the spam as non-spam. Okay, here, sorry, this is your non-spam, right? Predicting the non-spam as spam. This is a dangerous thing. Whereas here, sorry for the confusion. Okay, I just put spam and non-spam. That's why, right? You need to put the correct thing. So actually, it is a non-spam, but my model predicted it as a spam. Yes, correct only, right? So in that case, it will go to spam folder, the legitimate email. This is a very dangerous one. But in this case, it is actually spam, but my model predicted it as a non-spam. 2 emails, my model wrongly predicted is non-spam. See, non-spam emails consider as a legitimate email, and if it goes to your inbox, it is okay. You can accept. So in that kind of situation, you can, even if you find more number of values, you can ignore it. But this is very risky. The false positive should be less. Okay, now use the accuracy matrix. Let's see what happens. And here, true positive plus true negative. 2 plus 1 is 3. And if you add all the values in the denominator, you get 6 and 50%. So my classifier is pretty decent. Since it is detected nearly 3 divided by 6, 50% of all the spam messages detected. My model accuracy is 50%. That means, my model correctly predicted the spam as spam. Okay, at least in this case, it is fine. Okay, but let us take another example. So in this case, look here, let's take the same spam example. So if you literally go by the formula, true positive plus true negative, 0 plus 125, in the numerator, you will get 125. And if you add all the value, how much you'll get? 150. 125 divided by 150, we are getting 83.3. And if you raise your collar and tell your management, hey, my model accuracy is 83%. No, I did a fantastic job. Can you say like that? But when you look at this here, this is spam. Actually, it is spam. But your model, predicted no spam. Sorry, in the case of, the predicted, you see 0, right? That means your model did not even, your model was not able to detect the emails, the spam emails as spam emails, right? Here it says 0. That means, can I say I don't have any spam email? But when you look at this column, 25 emails are actually spam, but my model wrongly predicted as non-spam. Actually, this value is supposed to be here, isn't it? This value is supposed to be here. So here, I will just explain one more thing. My model says, my model predicted 25 emails as non-spam, but actually it is spam. This 25 should be there, but my model was not able to detect even a single email as a spam, whereas 25 emails are spam. In that case, if I use accuracy, it will completely drive everyone crazy, because your model says, hey, 83% accuracy, I achieved it. What is the point in saying 83% when your model can't even pick up one single record as a spam email? Actually, you have 25 spam emails are there. In that kind of situation, you cannot use accuracy. Okay, what else should I use it? That is where we have two other metrics that are available. One is precision, other one is recall. So in this case, the false positive and false negative. Look here, in this case, which one should be high? False positive. If it is false positive is high, will that have any impact? Or false negative, if that has more number of values, will that have any impact? Actually, it is spam, right? My model predicted non-spam in this case, right? Actually spam, but my model wrongly predicts non-spam. But in this case, not spam. In this case also, my model did not predict any non-spam. But if you see here, negative predicted negative. Okay, this is correct. Okay, it's a non-spam correctly predicted. But here also, okay, fine. But in this case, look here. Actually, it is a spam, right? My model, sorry, actually it is a non-spam. My model predicted as spam is 0. This is also fine, right? So in this case, the false negative should not be high. It should not be high, right? It should be ideally 0. Okay. So my model was not able to detect. And here also it should be 0, right? For example, you have 25 here. What will happen? It is a non-spam, but your model predicted spam, right? In this case, false positive, should be less. So if the false positive, values cost is high, if you think, yeah, in this case, the false positive, I cannot afford this one, right? Non-spam email should not be considered as a spam email. This is a very, I cannot afford. If you think the false positive cost is very high, right? So cost in the sense your finance part, okay? So in that case, or the impact, business impact. In that kind of situation, you can go for precision. Okay, precision. Now we will see what is precision. The proportion of correct positive classifications from cases that are predicted as positive. Out of the predicted positive, how many of them were correctly predicted as positive? Look at this confusion matrix. That's why I use this rectangle here. Okay, so with this we should be able to understand this equation. Look here, true positive divided by total predictive positive. I have used this positive column. Okay, highlighted the positive column. True positive. So which means my model predicted, right? This is the predicted thing. Predicted negative and predicted positive. You need to look at these two values. Okay, predicted negative and model predicted positive. So all these values put together will predicted positive, right? That is what your denominator. Out of this total predicted positive by a model, how many of them are actually positive? Okay. See, in a police department, they predicted, 10 thieves or 10 persons are culprits. Out of the 10 predicted culprits, how many of them are really culprit? That is what it says, the precision. And the next one is the recall. In the case of recall, it is in the horizontal thing. Okay, so this is the predicted. So in the previously we have looked at in all the values vertically. Now we are looking at horizontally. Okay, so in this case of this, look here, the positive, right? These are all positive only, false negative, because wrongly it considered as a false negative. Actually it is a positive. Actually it is positive. Hence true positive should be more here. Here it should be 0, right? Even if it wrongly predicted as something like 10 or 20, right? Both put together, the actual positive is 30. Out of the actual positive, how many of them were true positive? Let's say here out of the 30, only 20 are true positive. You got it? Out of the predicted positive, see, model predicted, and what is the actual thing. So it's in your record. You have written everything in Excel file or in a paper. The paper, as per the record, the person is good, right? So that is the thing you need to apply it. So the horizontal thing, if you remember it, it is good. The actual thing and predicted positive, actual positive. The denominator, now you understand it. Actual positive, out of the total predicted positive, how many of them are positive? That is what your precision. Out of the actual positive, total actual positive, how many of them are actually positive? Okay, that is what recall. So when should I use recall? If you think your false negative is very high. So in that kind of situation, you can go for recall. With this metrics only, you should be able to come up with a conclusion whether your model has done a good job or not. Recall shall be the model metric we use to select our best model when there is high cost associated with a false negative. When there is a high cost associated with false positive, look here, for instance, email spam detection, right? So okay, here in this case, yeah, if you think the false positive cost is high, then you can go for this precision. If you think the false negative cost is high, then you can go for the recall. So it is pretty simple. Okay, so you can remember this. In the interview they'll ask you these questions: what is recall, what is precision, and what is accuracy. Guys, only thing is it's all pretty simple. I explained it especially in today's session, everything pretty clear. Okay, and if you remember, only thing is you need to remember it. Okay, to conclude, now we have discussed about the model diagnostic metrics like confusion matrix, the precision recall, important metrics. Okay, and we will look at the ROC, UC, capacity statistic, concordance and discordance in the next session. If I cover it everything in today's session, you will be overwhelmed. I don't want to overfeed you. Okay, so we have seen as for the model diagnostics, we have seen precision, recall, accuracy, and AIC. AIC is same as linear regression. Let's say in a model you have 3 columns. If the AIC value is 100, and you have another model, you have 5 columns. For that, the AIC is 500. The 100 is bigger or 500 is bigger. 500 is bigger, hence it is not good. Lesser the AAC value, that is the model you need to choose it. So when I include these 3 columns, my AAC got reduced. But instead of using these 3 columns, when I use some other 3 columns, right, my AAC value is very high, then that model is not good. So this is some extent will help you AAC to find out the best model. But the confusion matrix, the accuracy, precision, recall will be very much helpful. Again, on a case-to-case basis, you need to take the call. Which one should you use it? I explained you when you need to use which metrics. Okay, and ROC, the rest of them we will take a look at in the next session. I'm done with it.